Hey guys, today we are talking about solving systems using substitution. All right, so let's talk about what a system of equation is. So a system of equation is two equations, and we're trying to find the solution to both of them. Normally, if I have an equation that has both x and y in it, I can't solve it by itself. But if I have an equation that has, if I have two of those, then I can solve using both of them. We're going to talk about how to do that today. So our first step is we are going to solve one of my equations for y equals. We could also use x equals. Doesn't really matter, but we need to isolate one of my variables. Second, we are going to substitute the value for y into the second equation, or in this case, the value for x as well. Then next, we are going to solve that new equation for our other variable. So if we're using y for those first two steps, it's going to be x. If we're using x, it's going to be y. Okay. Then we are going to substitute once again, or I'm just going to say plug in the value for x in either of the original equations to find my other variable. Okay. Then we're going to make sure that we give our answer a good check to make sure that we understand that it is the correct one. All right, so let's start here with number one. So number one, I have two equations. And that's the whole thing with that's the whole thing with systems of equations. So we have two of them. So I like to write them out beside each other. That really helps me. So I'm going to write out one is going to be y equals 9x minus 2. My other one is going to be y equals 3x plus 10. All right, so we have these two different equations. So what we're going to do is we want to create one equation that only has one kind of variable. Because if I have an equation that only has one kind of variable, I can solve that equation. So what we do here is I'm going to take this value for y. Let me change colors. We're going to take this value for y. This is what y equals. Y equals 9x minus 2. So I can take this value for y and plug it in for y in my other equation. If y equals this, then this y is also going to equal that. So I can rewrite this equation here as 9x minus 2, instead of having that y there, equals 3x plus 10. Okay? So there we have it. Now I can solve this equation. I can minus 3x to both sides. I can add 2 to both sides. It'll cancel these down, and I'll be left with just 9x minus 3x is 6x. 10 plus 2 is 12. I will then divide both sides by 6. Use a different color there. Divide both sides by 6, so x equals 2. So there is the first part to my answer. X equals 2. Now, once I know what one of my variables is, the rest is really easy. Once I know what my x is, I can take that and plug it back into my equation over here. Instead of having my x there, I could instead plug in 2. So I could rewrite this equation as y equals 9 times 2 minus 2. Well, of course, 9 times 2 is 18. 18 minus 2 is 16. So my y for this case is going to be 16. So my x is going to be 2, my y is going to be 16, and we write our solution in a particular way. We're going to write our solution as a point, as a coordinate. So my solution is going to be at 2, 16, with my x being 2 and my y being 16. Why is it a coordinate? Well, remember, if we have like y equals 9x minus 2, I could graph that. I could draw a line of that. That is a linear equation. I could also do that here. If I have y equals 3x plus 10, I could graph that too. And wherever they intersect, that is my solution. That's why we write my solution as a coordinate point, as an ordered pair with my x and my y. Okay? All right. So let's move on to number 2. So number 2, I'll move this out of the way here. Number 2, we are going to have these two equations. X equals 2y plus 5 and 4x plus 3y equals 9. Like I said, I like to write these out beside each other so we have plenty of room to work. So I'm going to write this one over here. I'm going to say x equals 2y plus 5. I'm going to write this one over here, 4x plus 3y equals 9. I put a break in the middle so I can make sure I keep everything separate. Okay, but now let's solve. Let's do this. First step, we want to solve for one of my variables. It doesn't matter which one. In my previous problem, y was already solved for, so I just used that. Let's take a look at this problem. Well, this problem, I have x already solved for. So I can take this value for x and I can plug it in for x on the other side, because that's going to create one equation that only has one variable, which is going to be y. So if I take this value for x, plug it in for x over here, we have to be careful. Make sure you put parentheses around it whenever you put it in. That way, remember to multiply to it. So we're going to keep that 4. We're going to keep that 4, but instead of having that x there, we're instead going to write what x is equal to. And x is equal to 2y plus 5. So once again, instead of having my x there, I have a 2y plus 5. So here's what I'm going to do. I am going to first distribute. I'm going to take this 4 and I'm going to distribute to get rid of this parentheses. That's going to make 8y plus 20 plus 3y equals 9. Okay, next, I'm going to do two things at once. I'm going to combine my like terms. I'm going to make 8y and 3y become my like term of 11y. Then I'm going to minus this 20 here and also minus it to the other side. So I'm going to have 11y equals 9 minus 20 is negative 11. Then I'm going to solve for y. I'm going to divide this side by 11, divide this side by 11, and negative 11 divided by 11 is a negative 1. So my answer is going to be y equals negative 1. So there is my solution for this one. I'm going to take it and I'm going to write it over here, but I'm also going to use my other equation to find out what my x is. So I'm going to take this negative 1 and I'm going to plug it into this other equation. I'm going to make this x equals 2 times, and instead of having a y there, I'm going to plug in a negative 1. So we're going to go 2 times negative 1 plus 5. Okay, so 2 times negative 1 is negative 2. Negative 2 plus 5 is 3. So my y equals negative 1, and my x equals 3. Now, it's always a good idea to take both of my answers and make sure they make sense in my original equation. So like I would take y equals negative 1, plug that in, plug 3 in, and see if it makes sense. Let's check it real quick. If I plug 3 in for x and negative 1 for y, 2 times negative 1 is negative 2. Negative 2 plus 5 is 3. Hey, it matches up. It's equal. So that's going to be true. All right, sometimes, instead of just asking for the solution, it's going to ask for the product of x and y. Okay? So that product of x and y, that's product means multiply, okay? It means multiply. So if I'm looking at the product here, what I'm going to do exactly that. I'm going to multiply these two together. The product of 3 and negative 1, 3 times negative 1 is negative 3. So there's my answers. X equals 3, y equals negative 1, and the product of x and y is negative 3. Alrighty guys, let's go ahead and turn that page, and let's take a look here at number 3. So number 3 is a little bit more complex, as you might expect. But once again, I'm going to start off by writing my equations beside each other. That's the way I prefer to have my equations so we have plenty of space. So I'm going to write this first one right here. We're going to write 6x plus 6y equals negative 6. And I'm going to write my other one over here. I'm going to write negative 3x minus 4y equals 2. Okay, so I do not have a variable solved for here. Unfortunately, we're going to have to put in some work on this problem. I'm going to first have to solve for a specific variable. Now, it doesn't matter what variable I choose, but I'm going to warn you. I wouldn't pick this one to solve for, because 4 and 3 don't go in evenly. I'm not going to be able to solve for this without making fractions, and I don't know about you, but I don't want fractions. So I'm instead going to look at this side, and I'm going to solve this one. Let's solve for x. So if I'm going to solve for x, I'm going to start off by minusing 6y to both sides. So I'm going to get 6x equals negative 6y minus 6. Cool. So that's going to allow me to now solve for x by dividing both sides by 6. That's going to cancel just like these canceled up here. And I'm going to get x equals negative 6 divided by 6 is a negative 1, so I have negative y. Negative 6 divided by 6 is a negative 1, so we'll have it like that. So I have negative y minus 1 is what x equals. So I can take this value for x, and I can plug it in for x on my other equation. So if I plug it in for x up here, it's going to be negative 3 times what we plugged in was negative y minus 1 minus 4y equals 2. Okay? Once again, instead of having that x there, we took this value for x and plugged it in there. And now I only have one equation, and it only has one variable in it. So I can solve it for my y. So we start off by distributing. Clear out this parentheses. So we're going to distribute negative 3 times negative y and negative 3 times negative 1. So we're going to get a positive 3y. Negative 3 times negative 1 is a positive 3 minus 4y here equals 2. Okay, let's do two things at once again. All right, you're smart. We can do it. We're going to combine 3y and negative 4y together. Okay, so 3y and negative 4y, they are like terms, and it's going to make negative y. Negative y. Let's try that again. Negative y. Okay, then I want to move this positive 3 over to the other side. So I'm going to minus 3 here and minus 3 here. So we're going to get negative y equals negative 1. And last but not least, to clear out that negative, I'm going to divide both sides by negative 1. So if I divide this side by negative 1 and divide this side by negative 1, we're going to get y equals positive 1. Super simple. So y equals positive 1. There's one of my answers. On the other end, I can take that answer for y, plug it back in over here, and so I can say x equals negative whatever my y is. My y is 1. So we go negative 1 minus 1. Hey, a negative 1 minus 1 is a negative 2. So we're going to get x equals negative 2 as my other solution. Okay, so now our last question. What is x minus 2y? I'm going to switch colors here, and I'm going to go over here to the side, and we're going to work that out. If I have 1x, that'd be negative 2, minus 2 times y. Well, y is 1, so 2 times 1. Okay, negative 2 times 1 is negative 2. Negative 2 minus 2 is a negative 4. So what is x minus 2y? It's going to be negative 4. Okay? So hopefully this is making some sense. Solve for one of my variables first. Take that, plug it back into my other equation. Solve that equation. And then use that to substitute it back in. It kind of has this rhythm to it, this flow. We take it here, plug it in here, plug it back in. Kind of makes sense. Once again, we can also check our answer by plugging it back in up there, but we're not going to take the time to do that right now. Just trust me that the answers are right. Okay, let's take a look here at number 4. So, number 4. Once again, I'm going to take my time and write these out side by side. So I'm going to write x plus y equals 5 over here. And I'm going to write 3x minus y equals negative 5 over here. All right, this one, hey, I don't have to divide by anything if I want to solve for a variable. I'm going to start by solving this side for its variable first. Why don't we move this x over to this side? So that's minus x here, and we're going to get y equals negative x plus 5. So now I know what y equals. And we can take this value for y and plug it in for y on my other side. So on the other side, we're going to get 3x minus, and then we're going to plug in where y used to be. Put parentheses around it to protect it. It makes it a lot easier. So I'm going to plug in a negative x plus 5 equals negative 5. Another real reason that we put parentheses is to remind us that we need to distribute to the whole thing. Okay? We're going to take this negative, and we have to distribute that negative to everything that we plugged in for y. So it's going to be negative here and a negative here. Well, a negative x is a positive x. And a negative 5 is a negative 5. So we'll have 3x plus x, and so on and so forth. Okay? So 3x plus x is 4x. We'll combine like terms here and here. But then I want to bring this 5 over to the other side. So we're going to add 5 to this side, add 5 to this side, and we're going to get 4x equals 0. So 4x equals 0. Then I'm going to solve for x. To do that, divide both sides by 4. So x is going to be equal to 0. And just 0, nothing else. So x equals 0. And it's okay to have 0 as an answer. Let's take that answer for 0, plug it back in over here. And so we'll rewrite it as y equals negative 0 plus 5. Well, 0 is still 0. Negative or positive is not either of them. So this plus 5 is just going to be 5. So we have my x answer. My x is 0. We have my y answer. My y is 5. And remember what we put whenever it asks for a solution. We put a coordinate point. My coordinate point is going to be at 0, 5. Okay, our last question here, my summary. My summary says, what does the solution to the systems represent? Well, remember, that's where my lines intersect, and that solution is the point at which those two intersect. So that's what I'm going to write. I'm going to say the point where the two, the two equations intersect. All right, guys, I hope today's lesson's been of some use to you. Remember, you can find the homework on goformative.com. This has been Notes for 3-1. All right, guys, have a good